Okay, welcome to this video. In this video, what we're going to be doing is looking at the Twerk 3D module creation interface and examining specifically how to create a worker thread pool. So, ideally, if you're going to have subsystems, they're going to have worker thread pools. So, processing between the entire application is kind of balanced a bit better. Um, and yeah, that's the whole purpose of this video is to demonstrate how to actually do that. So. The one we're looking at here is window to texture, texture map, or window to texture mapping engine subsystem. So the goal of this is to take a bitmap of a window and basically paint it to a texture. But we're not actually doing that in here. This is the beginnings of that module, so I just thought you would like to see how um, it's actually coming along so far. Or not that in specific, but how I'm building it and how to build your own. So first thing I did was I included these specific includes. These include the namespaces that are relevant to what I'm doing. Uh, it is important to include these. If you don't include these, your module could suffer. Um, I ripped these directly out of, I think, cinterface.cpp. And I just removed the spacing and whatnot. Here I have a defined window to texture engine module thread pool count. I set it to 5. That means it'll create 5 threads when we actually run the application. This can be anything you want. You'll see where it's used and how it's actually used in a little bit. So how do you start threads? Well, threads are in thread pools, and thread pools have to be declared as objects in thread pools. So let's look at the header file that comes along with this. So I wrote this as well. It's just it's a normal header, namespace window to texture map. It's important. Um, and I created window to texture map thread pool, which inherits off of thread pool and that. So here you can see down here, window to texture map thread pool. It's the constructor. You can see that it basically calls the parent constructor with window to texture pool as an argument, and window to texture engine module thread pool count, which was 5, um, as a second parameter. So this right here, this code right here is what is responsible for actually starting up the thread pool. Cool. Okay, so we're gonna go back to here, and if you remember when we set this up, uh, as soon as the engine starts, because of the way modules are registered and whatnot, this initialization routine is run as part of the engine startup initialization process. So this will get started as soon as all of the other subsystems or modules, I guess, are running. So as you can see here, window to texture map, which is the namespace from in here, window to texture map thread pool, which was the name of the class that we defined in here, and calling create singleton. This will um, this will start up all of the threads, get all the plumbing correct, and you know pretty much it'll launch our worker threads. We'll be ready to do what we need to do at this point. So yeah, just something interesting. So let's go ahead and continue this. Let's hold on. Actually, we gotta start it. So torque when main, you can see we only have one thread. Hold on, it's yeah. Click on it, nothing, just one thread. Okay, continue. Torque main, continue. Torque engine init, continue. Okay, still only have our global thread pool and our worker threads. Now, these were created before our modules were even executed, so as would be expected, here's our 8 worker threads and our 2 sound effects worker threads. These are the global ones, these are the sound effects. So if I continue,
speech subsystem initialized successfully.
I don't know if you heard that. It said speech subsystem initialized successfully. That was actually me utilizing my speech recognition engine module. That's not what we're looking at in this. We're actually looking at window to texture, which is just kind of cool. You can have text rendered to speech very, very easily in Windows. So, where are we? Continue. Okay, this is an example of using module namespaces, platform window manager. Up here, you can see, where is it? Window manager, platform, window manager. This is where that namespace is included, so you can call from out of there. The get method retrieves like a namespace variable which can be, acted upon. So here I'm just getting the area. As you can see, it starts off with garbage values. If I step it, we have actual coordinates. Kind of cool. Here down here, this is where we start the threads. Now remember, there were no threads. This is all it was. There was nothing on the bottom here. There was only this, and these. I mean, as well as the extraneous threads created by other things. So if we do continue, you'll see that try to create a couple threads at first. 1, 2, 3, 4, 5. Depending on how fast they're created or not. Sometimes they show up after, sometimes they show up during. But notice none of them have any names yet. Okay, so if I continue it, maybe they have names now. Here you can see 0 through 4 have names, the last one doesn't. If we continue, whoops. If we play, let's go in here and go, oop, clicked host on accident. Neat, huh? So let's do this. Wait, no. Oh, sorry, escape. Let's go here. Let's pause it. So the game was running. You could see the game running. And here you can see in the background, these 5 threads are still running. You can see the thread pool is window to texture pool, which is the one that we created. And they're usable for us. We could hook these up to, some signal processing thread or, something similar to that, which can be now utilized by the entire engine. I mean, at this point, we could register things with consoles. We could, do whatever we really want to do. But that's how you create a thread pool. I'll create another video in the future as to how to use thread pools, but that's how you start them up. Okay, that's it. Do 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 do. Stop.